Okay, so to start, I'm going to ask you to look at these two different statements. For the first one, I'm going to ask you to pick a position. The two positions are cats are better than dogs or dogs are better than cats. And then the other one, the statement is the easiest way to calculate 27 plus 8 rather. So 27 plus 8 is, you take a minute and pick a statement for that, an answer, but you also have to have an argument. You have to have a reason that you're deciding that that's what you're picking. So welcome. I am your host. I'm Dee Crescitelli. I am the director here at the Kentucky Center for Mathematics, and that is my contact information. You'll see that again at the very end of the session. And we are going to talk about debating in math class, and much of the resources for this come from this book, Up for Debate, by my friend Chris Lusniak, who is a super fabulous math educator in California, teaches middle school students, currently has taught high school as well. And we're going to think about argument as debate, right? When we think about debate, we more often than not think about either language classes or social studies. It comes up in those courses quite a bit and frequently in high school. But I want us to think about it in terms of math classes, upper elementary all the way through graduate school, because we ask kids to make arguments really in math class all the time. An argument is a statement made with sound reasoning. Sounds like things we're asking them to do when we work through story problems, word problems, sussing out what we need them to do in situations that are a little nebulous and ambiguous but involve mathematics, right? Every argument has two key parts. There's a claim, sometimes controversial, sometimes they're not always controversial. In true debates, they usually are, right? But it's a controversial-ish statement that's being made. And then the warrant is the justification for the claim. And so an argument is merely making a claim and then having a warrant for it, right? So where in math might we need justifications? That sounds like a word I've heard before.
Well, it's in our mathematical practice standards.
It's in the math practices. Thank you, Jacqueline. Right? It is in the math practices, right? So our, standards for mathematical practices in the Kentucky academic standards, in everybody's standards across the state of Kentucky, right? I mean, across the country, right? Ask students to justify their thinking, but also then critique other students' reasoning. That sounds kind of like a debate, not an argument as in we're yelling at each other, right? But an argument as in I'm making a statement, I am giving my reasoning behind it, and I can justify it. And I can either help you justify yours, or I can help you rethink it differently. We can have a math conversation this way. Okay. So one of the kinds of debates, because there's lots of different kinds of debates, but one of the debates from this resource is called the Soapbox Debate. And it's a really good one for intermediate aged students, right? So 3rd through 5th grade. I would posit this is actually super excellent for middle school and high school as well, but we're focusing on upper elementary here. And what we typically do is we start with arguments that are not math to start. We play with things where there aren't consequences, right? And we know kids like to argue. They like to sometimes disagree with each other about what could be inconsequential things. Those are safe places to start. So you pick one, you pick up a position. Cats are better than dogs are better than cats, right? And so, Jacqueline, which one of those would you like to stake your claim to?
My claim is dogs are better than cats.
And your warrant is?
My warrant is that cats tend to be more, they're just kind of aloof in my opinion. I just, like dogs are kind of, most dogs anyway, are.
So I'm going to ask you to state your claim again, but do my claim is what you said, and then your warrant as one distinct sentence. You've got a sentence. So
My
retry.
claim is dogs are better than cats. My warrant is cats tend to act a little aloof.
And you don't particularly care for that, right? So that would.
No.
So in a classroom setting, you would go around and catch 3 or 4 students to do that. They would, some of them will say, I have that same claim, but I have a different warrant. And you want to hear that. They have a different reason for why they like dogs better than cats, right? They may say, my claim is dogs are better than cats because they are way more fun to play with, right? But all sorts of things, right? So I'm going to give you mine because I am going to make my claim is that cats are better than dogs. And my warrant is because in normal times I like to travel and cats are easier to leave behind. They can mostly care for themselves, right? So you got different things that can happen in that debate. But it's a nice, safe one. No one goes home bloody over cats are better than dogs. Dogs are better than cats, right? It's a pretty fun way to start playing with this, right? So you introduce something with something that's not necessarily a math task. But this framing is very much tied to mathematical thinking, right? So if you need a literacy and math class piece, here's one right here. Another one, right? We had the math problem. The easiest way to calculate 27 plus 8 is, right? So Jacqueline, what was your claim and warrant for this one?
My claim is the easiest way to calculate 27 plus 8 is to do 27 plus 10 and then take away 2. My warrant is it's easier for me to add on 10 than to maybe try a different strategy.
There you go. And depending on your class, you may have kids come up with the easiest way because different kids may have other easier ways, right? And that gets to be another way for kids who, if you're doing number talks as a regular routine, this is another way to pull out the, you know, the work from the number talk, but sort of a different spin on it, right? Because they can claim this is the easiest for them. Other kids may have another easiest way, right? Or have the same easiest way and a different justification. And it's just a different spin on sharing the different ways that they are, you know, describing that. Now, the fun here is I would actually do the same thing. So my claim and my warrant would be the same. So I wouldn't have anything interesting to add to this particular debate. But there may be a student who says that my claim is that the easiest way to add 27 plus 8 is to do 27 plus 3 and get to 30 and then add on my remaining 5, right? Because I could go really easy to 30. I could go to the next 10 really easy, right? And so different kids may say different things.
I would say that the easiest way is 7 plus 8 is 15 and plus 20. Because when you look at it visually, the 7 plus 8 is right there. And I know it's 15 and then I add 20.
And that works, right? And in this case, because it was written horizontally, you're actually working right to left with which lots of kids were taught, but it's working that way. And you are analyzing it from a place value standpoint, ones with ones, tens with tens. Once you make those ones into a group, right, that has tens and ones, you can add it on and go from there. Perfect. Thank you. Another thing that's really good fodder that we see lots of in our classrooms, but this is a way to put a different spin on that, and in some ways, juice it up a little bit, because we get used, even these really good things get to be somewhat of a habit, and we don't necessarily get the math bang for the buck out of them that we could be getting. And so you can make a claim in a warrant about a which one doesn't belong. And this particular image lives really nice and solid in 3rd grade, but I would posit it makes a really good debate anywhere 3rd grade on up, because you're asking kids to actually think about it a little deeper than I'm just connecting those representations. We're asking them to connect the representations, but we're also asking them to make some real distinctions between them. So take a minute and look at those and decide what your claim and your warrant is. And so when either of you have one, you are free to share.
My claim is that 8 plus 8 doesn't belong. My warrant is that 8 plus 8 is the only one that uses addition instead of multiplication.
Okay. Cool. Cool. My claim is that 2 times 8 over here is the one that doesn't belong. And my warrant is, it is the only one that has these specific rings around the sets. It has the sets delineated out separately. So it has both arrays, but then they're circled like they're separate sets. Pam, do you have a claim and a warrant for this one? You don't have to if you don't. I just wondered if you did.
I was going to say that 8 times 2 doesn't belong because the counters are vertical instead of horizontal.
Awesome. And do you hear that math language, vertical and horizontal? Think about in this really quick, even if you only shared 3 or 4 of the kids' claims and warrants in your classroom, what other residual work you can pull out of that, right? This can be a really quick routine that then you back into for all sorts of stuff the rest of that day, the rest of that week, right? Can hit back to, right? Because all of these are fair representations of the same quantity, right? Big idea, they all end up being 16, but there are lots of different representations, and we can come with all sorts of different claims and warrants. The other thing I like about which one doesn't belong, but also this framework for which one doesn't belong in particular, is this is really good for access for all kids, right? Because it really could be as simple as one of them doesn't belong because this color is a specific thing, right? This one doesn't belong because all sorts of different things. So you can get at the vertical horizontal placements. You can get at, these all have 4, these are in groups of 4, this one's not. So someone can have the same claim that it's 8 times 2, but have a different warrant than Pam had. And so you can have some really good rich conversations about all the different ways that these arrays show the expressions that are there, right? Tying them to addition, tying them to multiplication, tying them to array work, right? Lots of rich mathematics in this one very simple thing. There's a website and it's listed there. And so is that showing you the website? Awesome. Which one doesn't belong has lots of them. So these are numbers ones, but they have shapes, numbers, graphs, incomplete sets. They have all sorts of amazing ones. So if you're looking for a website for lots of different things that do that, I would definitely suggest that. I will put that in the chat here in just a second. Any questions about the which one doesn't belong as an option for doing this? Okay. Oops, I went too fast. So some just general notes on doing this in a classroom setting. You keep it brief. This is meant to move fast, right? So 3 to 5 responses. You don't have a lot of lag time between them. You let someone explain it. If you need to help them reframe it to use the claim and warrant language, you do. Like I did that at first with Jocelyn. Like I said, give me just a good sentence. Give them 2 sentences at most to make their warrant. It's supposed to be succinct, right? Warrant and a claim. And then remind folks it's okay to repeat a claim. Like if you have the same claim, but you've got a different warrant, then we build on each other's thinking, right? We can make this could be the whole class if you want it. This can be a let me jump in and get started with this and use it to go into something else. But you as a teacher control the timing. You have 2 or 3 good arguments for a question and move on. But you could also decide if you've got really good stuff that you're getting from kids and you want to keep the debate going, you can decide to do that. You can have one good meaty question and get a lot of mathematics out of it, right? We got a lot of good vocabulary out of 3 quick ones that weren't related at all. You could have 2 that are related and, you know, spend the rest of the week pulling out all the rest of the mathematics. It just depends on what you choose as the prompt, right? As the thing that you want students to make a claim about. Another idea is the always, sometimes, never, which is just a great routine in general, but it's perfect for an argument for a debate framework, right? So my claim is, looking at this particular one, the fraction with the larger numerator is the larger fraction. Is that always, sometimes, or never true? And you can make your claim and your warrant.
So my claim is that sometimes the fraction with the larger numerator is the larger fraction. My warrant is with this. So like what we expect students to give like an example of a non-example maybe?
They could. That is definitely a fair game for a warrant. Yeah.
Because I'm thinking if I have a situation like I have 5/4 and I'm comparing that to 6/12, my 5/4 isn't the larger numerator, but it is the larger fraction. And then I could give an example where that would be the opposite would be true, where so I could use 6/12 again, but also do 1/3. And in that case, the larger numerator, the fraction with the larger numerator is the greater fraction.
That is correct, right? So kids could do that, examples and non-examples, which always, sometimes, and never is really good framework for making a claim, right? But I can see you pull this out in a 3rd grade, 4th grade, even a 5th grade classroom, you're going to have kids with different claims and different warrants because, and in this case, you have to tie it back to what is the whole I'm tagging the fraction to. If I'm comparing things that are coming from different wholes, right? So I have the same claim with you that it is sometimes true. My claim is that that is sometimes true. And my warrant is, it depends on what I'm claiming as my whole. Because if I have a whole large pizza, right? 1/3 of that is going to be smaller, right, than 2/3 of a small pizza, right? And so it depends on what I'm referring to as the whole. So if I'm talking about two different size things to start with, my fractions might not compare well at all, right? And you can have a whole class on, oh my gosh, I have to tie that back to, I mean, that's a great introduction to fractions refer to parts of the same size whole. Like I can only compare them if I'm referring to pieces that are the same size whole. And that's both a 3rd grade and a 4th grade standard, right? Pretty great mathematics you can pull out of that. At its basics, extended response is a claim and warrant situation, right? If you spend good time with students, having them say, this is what I think, and this is why I think it, they're better prepared for extended response questions in every subject, but that particularly matters for us in mathematics, right? So this framework can be used to help students expand their thinking in written form. We ask them to think about math with words. We ask them to write about math in words all the time, except I'm not sure we're giving them enough practice with that. So this framework gives them some practice with that. So you can take 3 or 4 what would be practice problems, right? And instead of giving kids a worksheet with a whole bunch of, I need you to practice doing these things, you give them 2 or 3 or 4, right? Maximum of each of these things has this thing that you want them to do. In this case, it was comparing fractions, and determine which of them is larger without using a calculator, if that's what matters to you. And it does for all of these standards, right? In intermediate grades. Be sure to claim which is bigger. Make sure that you claim that with a warrant, right? And so then they're explaining their reasoning to you, which is what we want them to be able to do. So it's a really good framework to give kids for practicing, right? Here's what I did. Here's how I knew that. This is what my thinking was. But it also helps them write that with words, because we need them to be able to say it, we need them to think it, be able to say it, but also be able to write it. Questions about that?
No.
Okay. So the author of the book did a presentation for the global math department, little series of things, and he talked about why debating in STEM in any of the classes. So math, science, technology. I could posit you can have debates in any subject at all. We could debate in art class, right? But it's a good way to engage. If you've got large classes, it's a snappy, quick thing. You can grab a few people. You can grab different people the next day. If you only do it, once a week, but it becomes a routine thing, kids know to expect it. However you want to structure that in terms of the routine. There's some research about it improves graduation rates and college readiness, debating, being able to articulate your arguments and defend them and critique the reasoning of others. Like that's a math practice for a reason, right? It's a skill that people need to use and use lots of in college, right? In the study that they referenced in this presentation, part of it was just finishing high school. Kids came because this was not boring and horrible, and they didn't tune out. That's great, right? There's some Danielson connections if you want to frame that back to some of the way that we structure the way we think about teaching and learning in the state of Kentucky. We tie a lot of stuff to that Danielson framework, and this actually ties really well to classroom environment piece of that in particular, but some of the lesson planning and what control kids have of things in the classroom. This is a big student agency piece as well. And then we talked about math practice 3. If you're a Kentucky person, those are coded into our standards at this point, right? And other folks in other states watching this ties directly back to that math practice 3 that lives in so many of your standards. There's a hashtag. People put hashtags up for sample problems and all sorts of things on Twitter. So if you're a Twitter person, that is there. Debate math, luzniak.com/debate math HTML. I'm going to take you to that website. So it comes from a book, but he also has a website that has all sorts of resources that you can use. You can subscribe to the mailing list. He also has a blog that has some pretty awesome stuff as well. So we could click on the blog. And he gives all sorts of stuff. He writes, generally speaking, at least once a month. He's not written in November yet, but he puts all sorts of things. Other folks give him examples and respond, and it's just pretty darn cool for those things. I will put that link in the chat when we close this part out. That's me. That is a quick snippet of debate math. Thank you very much for joining me. All sorts of amazing things can also be found on our website, www.kentuckymathematics.org, or bonus, www.kymath.org, which is much easier to remember, also works. And we are super happy to support you. This is the last scheduled one of this series. We're going to put together another series of opportunities, and we'll keep you posted.